Hey everyone, how's it going? Woo, yay! All right, and also, how about lunch? That was really awesome, yeah? At least I thought so. Hi, so, now that you got that started, you are here for my talk on what is NetDevOps and why. I am Leslie Carr, and if you didn't know, we are at SREcon 2016, so hopefully you're in the right place. I also want to remind everyone, this is a very visual talk, so I'd recommend that you put your laptops down for a little bit, because I promise you, everything will still be completely broken in a half hour. So, and it wouldn't be a talk if some of my stuff wasn't also broken, isn't that right? There we go. So, who am I and why are you here listening to me? I've been in the industry for about 15 years now. I've been an operations engineer at couple big websites you might have heard of, like Google, Craigslist, Wikipedia, and my most recent position was at Cumulus Networks. And I am currently a fun employed bum, which is an excellent life for anyone. And who are you? Well, hopefully you're either a network engineer who's automation curious, but you're still running your network in a traditional model, or you're a systems engineer who loves your network engineers and you want to help them make that big step forward to automate. So if you're already automating everything in your network, congratulations. I take back what I just said. Pull out your laptop, check your email. That's all good. So today, I'm going to take you on the first steps of taking your infrastructure from the legacy model to working with your networks in the DevOps model. But what do I even mean when I say DevOps, right? Everyone's heard it. It's such a buzzword. If you ask 100 people, you're going to be getting 100 different answers, or maybe even more. But really, what I think is at the core, for a long time, developers and sysadmins didn't communicate, and that caused a lot of friction and problems between the teams. Yeah. DevOps was the idea that when your teams work together, all of your production is in a better state. But also, most importantly to me, is that your infrastructure is now thought of and described by code, using some great tools like Puppet, Chef, Ansible, or Salt, or many more. Your infrastructure is completely managed, completely described by code. There's no more logging into systems, right? So today, in the systems world, we're in a better place, right? Look, the dog of ops is working with the pony of dev to lead the kitties. So DevOps is leading the pack, right? But the problem is that the network is still the kitties. The network is still just being pulled along because traditional networking methodology has been pretty old-fashioned, right? So usually, say you get your new switch. You're logging in manually, often with a password, right? You're typing in commands on the command line, and who here has never typoed a command in their life? Like, come on, right? No one. It's impossible. Or sometimes you're cutting and pasting over console. Very common. Some vendors have rollback, but others, if you didn't, remember what your config was beforehand, you didn't have it saved, good luck trying to get back to it. And Rancid's really been the only decent tool to save your configuration state. Rancid's not bad. It does what it does, but it's still sort of working in this old-fashioned mindset. And typos can, and probably have, brought down your entire network, right? So why? Why are we still like this? Why are we so old-fashioned? Well, for all of us in the systems automation world, I think we forget that our tools have been around for a really long time. So let's make a little more interaction. CF Engine is often thought of as one of the first, at least major configuration management tools to be out there. So does anyone here know when it was written? Oh, you? Yeah, it was written in 1993, right? And so Cisco's 1PK, which enabled automation on a lot of Cisco platforms, was only released in early 2014, right? That's a lot of time between these tools. So easy tools to automate your network are still pretty new. And without the help of tools and without the help of networking vendors to interact with the tools, it's not a surprise that networks have been stuck behind. But you don't need to fear. Automation is for everyone. And I'm going to show you how to get to this, the promised land of network engineers and systems engineers working together to make our lives better. So I want to address a couple of common complaints that I hear about automation in the networking world. It's a fad, but I think as we can see from the systems world, it's been going on for a very long time. It's not a fad, it's a necessity. It's hard, it's true. Learning a new skill can be very hard, but network engineers have made the internet run. Like, hello, that is one of the hardest things to do in the world. So I think network engineers can do very hard things. This will steal my job is another very common problem I hear. But one thing I've noticed is that jobs almost never are stolen. Your budget usually doesn't go down, and you get to learn all of these cool new tools, and your network is probably going to have greater uptime. One wrong move will bring everything down. That's true. However, with testing, you can make it less likely, because right now, one wrong move has no testing and already does bring everything down. My gear doesn't support it is starting to be less and less true. Thank you very much. But I'm still going to show you some steps you can take even if your network gear doesn't support an automation client. And the biggest problem that a lot of these really are wrapped up in is I don't know where to start. But you're here today. We can get started today. It's time to start trusting the computers. Because the internet is built on trust. BGP peering is just 100% trusting that the other network engineer is not going to send you the wrong things, right? We could do this. So look, you have a lot of choices of where to start. Look at all these logos, so many vendors, so many logos, right? It's great. You don't have to be a great programmer is one of the best things about this. You can cheat, you can use one of these awesome tools that other people have written, and there's a lot of code out there on GitHub that other people have written. Steal it all, Stack Overflow, another great resource. And so the biggest problem is really social and not technical. So now we're going to start learning. Before I start, I want to remind everyone, since my most recent job was for Cumulus Networks, my examples are written for them. However, good news, this can work on any vendor platform. Most major vendors are even supporting Puppet or Ansible or another major automation tool. And even if your gear doesn't, I can show you how to get a good chunk of the way there to improve your network. So step one is start using Git. Right? Git, you could really think of it as just a text file repository. Right? It's got automatic file revision and change management. It's really built for lots of people to be working on the same files at the same time. It's really easy to get started with. And there's a lot of knobs for more advanced users. So GitHub is a really great way to start if you've never used Git before. They've got a nice little introduction right there. It's free for public repositories. If you don't know or care about running your own Git repository, you can start there. If you want to have a private one, they have pretty cheap private ones. Or there's a good chance that some other team in your company is also already running a Git repository. So you can just use theirs. So there's a couple of tools, buzzwords, I guess, you need to know. Or the remote repository is the other server that hosts your files. Local repository is your local copy of those files, like basically the copy on your laptop. A branch is when you make another copy so you can make changes. Branches are very useful. You're like, hey, I want to make a new weird BGP change. I'm going to do it in another branch so it doesn't affect any of the configurations running now. And then merge is when you apply all of those branch changes back to the master. Also, we often will hear the terminology pull requests. Same thing, pull requests is just another way of you're requesting to initiate a merge. So step two, you cannot start automating without knowing what you have. You need to check in all of your configs. You are going to find that one or more firewalls that has that admin who quit 5 years ago in a huff and they still have their login and you're like, oh no, you're going to find everything. It's going to be horrifying, but it's okay. This is where we start. So if you just want to see a nice little change in GitHub, if you can look here when you check in your configs, then you can see what's changed. It's really great. And step three is you need to templatize your configuration files. When you think about it, a lot of your configuration is going to be the same, switch after switch, router after router, right? You're going to have some sets of groups, perhaps VLANs, perhaps not. You're going to have the same syslog server, the same NTP server, the same user accounts. So there you go. And And computers don't make typos. That's the best part, right? You get to eliminate a lot of places where you can have human error. And you don't even need to have your configurations push out automatically yet, right? You can have config management create all of your configurations, and then you can cut and paste it. So it works for legacy gear, and also if you're too worried about having a computer automatically touch your network gear. So I just wanted to show you a really simple configuration file. This is using Puppet, just because Puppet's the thing I know best. Yeah, there's tons of great languages out there. Choose your own. We're going to define a new type called switch config. You can see it just put in the loopback. I put a few ports into different VLANs. Kept the information nice and brief so it doesn't take up too much of the slide. Then here's a nice little template example, right? It just gives you your loopback, some VLANs. There you go. And ta-da! This will now output this exact configuration file onto a server of your choice, right? Bam! You've just transformed your configuration into code. Great news, right? We're all done? No, the bad news is that we're still stuck in silos. So raise your hand if your systems and network teams are separated. Yeah, it's pretty common. Looks half, 2/3. Raise your hands if they work together. All right, that's about a third. That's pretty good, right? Teams often have ticket walls. A great example of a ticket wall system is a machine turnup, right? You're going back and forth between the network and systems team, right? Like the systems team has to wait on the network team to assign a port and a VLAN, and then the network team is like, dude, I have 1,000 things to do. I don't want to just be logging into a system to put in a port. This is a frustrating use of my day. And then, oh no, look, this server isn't actually a web server, it's something else. We need to change all the information. It's really frustrating. Instead of feeling like you're working together on the same goal, it feels like both sides are just either holding you back or filling up your day with junk work. So Git branches are to the rescue, right? Look, we're adding a new machine to a new VLAN. You can make a new branch. The systems team can make a new branch, and then they can use a pull request to the network team to actually pull in those changes. So you get the security of having the network team do all the reviews, but then they also don't have to do the work. GitHub is just a nice little graphical way to see all these changes. Makes branching and pull requests really easy. You just push a little button. Look, you can start your pull request, put a little thing what you do. Someone else can approve or deny the request. If it's not in a test repository, you aren't approving your own requests. Pull request is approved. And Git, you could restrict who can approve the changes. So you have your cake, you eat it too. You get your security that you get from silos, but you've also removed the ticket walls between the teams by letting the systems people and the network people work together. Now we're working together and life is good, right? So there's a couple of advanced topics. There's so many more tools you can use. That would be an entire presentation all to itself. But I'll just mention the two things here that I think you can get the biggest bang for your buck, so to speak. Continuous integration systems can run checks on your code every time you check it in. So Travis CI is a good free online option, and Jenkins is another free open source project. In many workplaces, if your network team isn't already using it, there's already some other team that has a similar system. You can just use theirs. Like I said, it's not about doing a lot of work yourself. It's just about reusing all of these existing tools. And one of the great things about these is that catching typos. I'm incapable of typing some words correctly, right? So now, but I have Jenkins. I have a list of words I commonly misspell. I try to push it in. Jenkins will refuse my push saying, you misspelled this word, right? There you go. You solved 95% of your typos. And for extra advancement, you can write some more tests around your configuration to catch other common issues. And then you can virtualize a copy of your network. Every vendor has their own virtualized platform. Some are for free. Some cost a ton of money. GNS3 is a great open source option. Free, supports almost every platform out there, so you can make a virtual copy of your network. So now, when you want to do a new BGP scheme, you can test and tweak it before your 2 a.m. maintenance window to find out that it works. Because I don't know about you, but at 2 a.m., I'm not in a space where I'm going to be debugging these things. right? Honestly, my biggest problem with virtualization is after I got hooked, I wonder, like, how can I test out new configurations without this? And then the last thing, you can take a leap of faith and install the automation client directly to your switches and routers. As I said before, not all equipment has this ability yet, but one of the great things, the networking industry is a capitalist industry. Every person who runs a network here is the demand, and if you demand from your suppliers, it will happen. So now, yay, we're happy, everything's great, right? But if everything's great, I still have time on my talk. So you're thinking this sounds like a great idea, but then what happens when something goes wrong? Something always goes wrong. So here's the configuration snippet I had before, but look, instead of a /32, I did a /3 on my loopback. This is gonna cause some problems, right? Yeah, exactly. I know the exact typo of typing /3 instead of /32. I know several websites it's caused downtimes for, right? So you're probably using peer review, but maybe your reviewer also hasn't had their coffee. You push the config out, and oh no, boom. Yeah, your website's down, your pager's on fire, right? Yeah. You're trying to rummage through you don't want to have to rummage through all the changes to figure out what went wrong. But git revert is to the rescue here. Since Git keeps track of every incremental change, a git revert can quickly undo to the previous state. So this way you can get back to a great safe state. Here's just a nice little example. There we go. This is just reverting back one step. So you can be like, hey, look. All right, now my configuration is in a safe state. Just remember, when you make a commit, it is only reflected on your local branch to push it back to the remote branch. When you're in a panic, sometimes people forget this. That's to make sure the fix is propagated. So, now we fixed the problem. We have some breathing room, right? So this brings up my favorite part of DevOps culture, which is the postmortem. Because without a postmortem to tell you what went wrong, you're just wishing it doesn't happen again. So I think postmortems are the best part of the DevOps culture. It's all about finding ways to improve your process to make sure technical mistakes don't happen again, right? It's not about assigning blame to a person, but blame to a process. You do have to be completely accurate. Let's say I broke into the data center and was doing a drunken handstand at 3 a.m. and I bumped into the rack, caused it down. I need to own up to that, right? Yeah, I know. It's horrible. But then the last part is my favorite part, is how we enact institutional change to prevent this problem from happening again. For example, we could install breathalyzers on the door to the data center, so I can't do that anymore. Or more practically, we can also write a test to check for that configuration mistake we just made so it doesn't happen again. So we have to all remember, failure is okay. You want everyone to feel comfortable admitting when they mess up. We're all human, we all fail. So now you've gotten rid of all of your drudge work, you're moving from this to this. So just to remind you what I went over, step 1, git, check in all of your configurations. Step 2, change all of your configurations into code by templatizing them. Break down your silos and your ticket wall by encouraging your coworkers on other teams to help with pull requests. Remember that for extra credit, you can use continuous integration and virtualization to help contest all of your configurations before you deploy. And then you can use Puppet to pull all the changes automatically. And now you're on the journey to the promised land of teamwork and NetDevOps. So, any questions? Just please come up to the mic if you have any. All right, cool. Well, oh, yeah.
So I have a question. I'm really enjoyed your talk, But I have a question is, you mentioned some of network engineers, they may concern about the rollback.
Yes.
In your methodology, how would you solve this problem? They use GitHub, they use Puppet, and the checking everything to the devices. How do they roll back? That's my question.
So the one way, I think it's very important to make sure that you have a single source of truth, just like you do in systems. You know, I'm going to admit, I'm sure everyone else here has, when their page is on fire, logged in directly to a machine and made a change. It's very important that you make that change in the Git repository. Honestly, I feel that having you know, an agent-like system, a pull-like system that enforces your changes, enforces this behavior, someone's going to mess it up. But you know, if everyone knows that their change will be overridden unless it's in the master repository, I think that really helps with the social problem. So you can either do, if you have connectivity, you can do a git revert and then push the new fixed configuration. If you don't have connectivity, you can at least do a git revert to get the correct configuration, go in via your out-of-band system, and then cut and paste the correct configuration in. Yeah.
Thank you.
You're welcome. All right, yeah. If you could go to the mic so the recorded people can see what I'm answering.
Just a comment on the not editing them directly, just like you were saying. The systems you're talking about can actually let you detect when changes have happened out there, right? Because instead of pushing and stomping, you push and compare.
That is true. You can do that as well.
So you can set things up and say, look, sorry, you can't push because your colleague broke the rule, and then you go find them and
you can do that. I'm a meaner person, and I'm always push and overwrite, but actually it is also a very good idea, especially for some systems, to have it send a notification instead.
So it looks like you're dealing mostly with on-prem stuff. Do you do anything with like cloudy AWS stuff as well?
Well, the problem with AWS networking in the context of this talk is this is more aimed at people who are running their own physical networks. Mm-hmm. AWS networking, since all you're doing is an API, it's you don't have the same problems. I mean, you can automate all of the calls to that as well. So yeah, it's just a different way of thinking about things. Because really, if you use one of the cloud systems, you still have a network, but it's not your problem.
Really liked your talk. All the best talks have cats in them.
Thank you.
Can you explain a little bit how in the organizations you've been involved with, you've overcome resistance from networking groups? If you've encountered it?
Yes, well, some organizations I've overcome the resistance by leaving myself, which is a thing. Other organizations, like Google, for example, has a lot of software development already, so they have this mindset. Actually, at Wikimedia, I think is where I really got more into the automation in the networking field because I saw all these great tools, and I decided we need to start using these on our network as well. And there was actually surprisingly little friction. I will go way over time, but if you want to find me, I can head out to the hallway after this, and we can discuss more about some of the tools. It does require support and social engineering sometimes. But a lot of times when people realize how much time they've saved, it actually is nice. Like, there's that scary learning hump. But then when you're like, oh yeah, I don't have to create a configuration, like the next time I'm deploying a new data center, it's so nice. And especially virtualization for me. Virtualization was like the big win. Code configuration changes are scary. And if you know that it's going to work, it helps you out a lot.
Thank you.
All right, yeah. I'll be back in the hallway for any more questions or long discussions. Feel free to find me. I think I'm a little visible.